All right. Welcome everybody. Welcome to the webinar. My name is Andrew Jones at Climate Interactive, and I'm here with Caroline Reed and Clara Iglesias. Welcome everybody to the webinar. You are in the right place if you are here for the En-ROADS Climate Workshop. We're going to dig into this important issue for the next hour, but first, I want to hear who you are and where you're coming from. And we're going to do that. I'm pulling up a map. We're just so curious to see where you're coming from. And we're going to do this with a poll. And at the top, you can see, and Clara, would you send around the link of pollev.com? See that link at the top? Go to pollev.com/climateinter935, and you will see this poll, and we'll use it a good bit in the workshop, and use it to click and show us where you are today. Oh, there's someone already. Taiwan and China and Australia, New England and England, Scandinavia, Europe. We'll be using this a good bit. Someone in India, Mexico, and Clara and Caroline, if you do see places that you recognize, let us know. Middle East, Moscow, some Indonesia. Wow, people are all over. Now 2 in India. Wonderful. Several in China. I think that's Beijing. And now West Australia, many in New England, in the US, Canada, Northern Canada. Welcome. People are coming from all over the world. Fantastic. If you're just arriving, my name is Andrew Jones. I'm here with Clara Iglesias and Caroline Reed. And you should go into Poll Everywhere, see that link at the top, or look in chat and click a dot about where you are today or where you're from. 2 clicks if you like. Italy, the Middle East, South Africa, middle of the United States, many out in Asia, several in India, China, Russia, many in Europe, in the UK. The UK, is that some in Glasgow where we're going to have our international negotiations soon? Welcome everybody. So please keep on clicking and letting us know where you are. In a second, we're going to actually let you unmute and say hello in your favorite language. We want to really know who's here from around the world. So if you're just joining, this is the En-ROADS Climate Workshop. We're going to use our simulator En-ROADS to think about what we can do to address climate change, particularly given some of the challenging news we've had on the impacts of climate change. We'll be using our simulator En-ROADS. Clara, maybe you could just go ahead and send the link to it. En-ROADS is our simulator that we'll be using in this exercise. So folks are coming from around the world, love seeing these maps. All right, we'd love to do another thing with just a greeting. What we're going to do is we're going to unmute everybody. And then I want you to say hello in your favorite language. You may want to wait a few seconds until it dissipates a bit, but we just love to hear the voices of you critical partners who are making a difference on climate change. So Caroline, could you go ahead and unmute and we just say hello to everyone on this in your favorite language.
Hello.
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 Good morning.
Hello.
How do we?
That's crazy.
Everybody can come and sit with me. Come on.
Wonderful. All right. Thank you. All right. Welcome back, everybody. Again, this is Andrew Jones at Climate Interactive with Caroline Reed and Clara Iglesias, and we're going to jump into the En-ROADS Climate Workshop. If along the way you want to tweet about what you're hearing or anything that are going on, here are some of the handles that we use. And if along the way you have questions, some of them, if they're easy, you can just drop into chat and Caroline and Clara might be able to answer, but you know there are a lot coming by because there are over 100 people on this webinar right now. But if you have a deeper question, go to this site of our support site. There are hundreds of FAQs, but also a chance to submit a ticket and ask a more formal question. We're a nonprofit think tank here in the United States. We work closely with MIT Sloan School of Management and their sustainability initiative. And we're going to use a workshop that we have run with many people. And this has been tested particularly with US policymakers. Here we are, it's John Sturman, our MIT partner and modeler, and Michael Sonnenfeld with John Kerry, the US climate envoy, who says it's a simulator is a crisis game changer. Had a chance with US House of Representatives Congressperson Lisa Blunt Rochester, creating her 2-degree, 3.5 degree Fahrenheit scenario here. And also people from many different political backgrounds. This is with John Curtis, who just started the United States Conservative Climate Caucus, talking about how he's found En-ROADS helpful. And Jay Inslee, a presidential candidate and a climate leader. People are using it around the world. This is a map like the one you just created. 2,500 events like this one. And these are, of course, events that you can lead if you choose to learn how to do it. There are events around the world. People have sent in pictures of them on the couch with their family or on Zoom in many languages around the world, engaging other people with this simulator. So the main thing today is we're going to think about climate change, but the secondary invitation is if you want to learn how to do what we're doing, we now have a full training series. Clara, can you send the link to that? It's an 8-part free online course, 63 very short videos and quizzes and exercises that teach you how to engage other people with this tool that's now available in 12 languages. You could become what we call an En-ROADS climate ambassador. And I think there are a lot of people on the phone right now who actually may be coming back to the workshop who are those ambassadors. In fact, write into chat right now if you are one, maybe just a word or two about what you like being an ambassador. If you are out there, our ambassadors, speak up in chat right now. There are 340 of you around the world, actually more than 340. Okay, that's enough of the pitch about what we're doing. The big question, the big challenge, and why we're really here, I'm gonna pull up another poll. Of course, let's get grounded on what we're here to think about. And that is addressing climate change and climate-related equity. It's of course wrapped up in this challenge. So go to the poll site. What are the specific impacts of climate change that concern you? Of course, I could send what concerns me and all the pictures and headlines, but this is coming from you. Sea level rise. Thank you. 2 people, sea level rise. Lack of government action, that is an impact. Heat, we saw some of these events around the world in the Middle East, some here in the Northwest of the United States, 2 of them with heat waves. Air quality, PM 2.5 emissions, kills 1 in 10 people around the world, says the World Health Organization. Resource wars, more conflict built around people getting competition for resources, or climate migration, flooding, heat waves. 20 people just died a couple hundred miles from me just 2 days ago. Flooding, just water, lack of it, too much of it, or it rising on the coast. Heat waves, wildfires still raging here in the United States, and pardon my US focus, but that's what I hear about. Species loss, extreme weather events, flooding, absolutely. These are what we see around the world. Reduced food production, crop yields perhaps going down, people moving because of those challenges that they see, refugees, food, loss of biodiversity, the loss of forests, the loss of ecosystems of other creatures around the world, fires and floods, extreme events, crop disruption. Absolutely. All right. So, given animal extinction, given all of these challenges that we see, what can we do? So what we're going to do together to think about this challenge is to pull up and think about together what we can do to have this situation be addressed as fully as possible. We're going to address it using our simulator called En-ROADS. And if you're totally new to this, this is an online free simulator. Clara, if you could send it around to everybody in chat, that's available in 12 languages. And it tells a story of the future and allows us to think about what different futures we could create. So here's the baseline story that we've chosen. The baseline is not our prediction. This is not the most likely future. This is a possible future that we're going to test various policies against. And in this future, look over on the left, you see from 2000 to 2100, this is a future with more coal, more oil in red. Blue here is natural gas. The green is this growing area of wind and solar. We're going to look more closely at it. It's really remarkable how much we anticipate wind and solar growing, renewable growing exponentially throughout the century. So a good bit more wind and solar. On top of it, a little bit of bioenergy and a tiny bit of nuclear. If we have all of those emissions of carbon dioxide and you add in from deforestation and from methane and agriculture and nitrous oxide and the F gases, that gives you this graph on the right, which is greenhouse gas net emissions. Some people say, oh, climate change, science is hard. No, it's not. There's this pollution and you're looking at it. It's the stuff called the greenhouse gases. The more we put into the atmosphere, the more that temperature on the right goes up. The more that it falls, that pollution falls, then we have temperature not rising as much. So the goal is to get to what people call net zero by mid-century. Can we get this line of greenhouse gas net emissions down to, well, there's net zero by mid-century. That's the challenge that we're going to take on here today using the simulator. Now, one note about this, we built En-ROADS using the best available science with our partners at MIT Sloan, using data from sources such as the IPCC. We're about to adjust it based on this new report that came out last week, the International Energy Agency, and particularly comparing our results against those of other studies, other models around the world. There are these beautiful models called integrated assessment models that are huge. They take overnight to run. They're published in research papers, and they put all of their data out on the web. We pick it up, read their papers. Here are the names of all 6 of the main ones that we're looking at on the right, from the Netherlands and from Asia and from Austria. IASA, PNNL is here in the United States. And when they put those studies out, we can put their lines on the graph here from 2000 to 2100. Here is their baseline for this scenario, SSP2. See those red lines? Each one of those X's are one of the studies where they think a baseline would go, and then various reduction scenarios. So what we do is we test our model against their model. And then that's what I'm showing you here is our lines to see, oh, can we build our confidence in our model to see, are we replicating the same kind of results when we put in, say, a carbon price in En-ROADS, a similar one that they put into theirs, do we get the same kind of result? By the way, if you like geeking out on this, you should take the course because there's a whole training on these kinds of tests. Some other things we do to build confidence, of course, is we publish our results in the world, and we have a 400-page reference guide that allows us to show all of the equations to you, open source. Also, if folks don't really like the result or like the assumptions that they see, many of the assumptions can be changed here in the model. So you can go in and see, for example, the climate sensitivity to a doubling of carbon. Oh, by the way, big news came out of the report a week and a half ago. The range of this biggest number in climate science, the climate sensitivity, has narrowed. We're more confident of how it is a bit more narrow in actually, Caroline, can you, thank you. This number, which is really important and governs how much warming we will get, we now are confident that it's a little more clear about what it is, that the range is a little bit tighter. But my point here is you can change important factors in the model to see in real time what would be the implications of this if it was the range of 2.5 to 4 or so, which is the range that's now being considered. Okay, so that's enough about how we build confidence in the model. Let's start thinking about what we can do about these challenges. Okay, if we're headed to that world that you just saw, that we don't want to see, with societal breakdown and animal extinction and extreme increased frequency of these kind of events, here's the big question to you. First question, what are often praised policies? Things that people are talking about doing, but you may think, actually, this is not quite as important as some others. Let's start with, what are we talking about doing? Electric vehicles. Actually, Caroline, can you read these? Because I'm going to write some down here on my piece of paper. I've got my paper here.
Sure.
Can you read them as they come up?
Yeah, switching off the lights, a take on the popular trillions of trees, so planting zillions of trees, blue hydrogen, unplugging appliances, another for planting trees, consumption as a problem, composting, nuclear energy, recycling, nuclear, your personal carbon footprint, carbon capture, another for carbon capture and storage, back to recycling, population as a general factor. Yeah. Concentrating on consumer-only responsibility, forest carbon offsets. These are great.
Yeah, this is really great. You're doing it right.
Solid waste management, lots of people chiming into the recycling. Hydrogen.
Great, fantastic. Okay, this is exactly what we needed. All right, so we just heard so many: electric vehicles, personal action, trillion trees, population, nuclear, carbon capture and storage, forest offsets. So let's explore some of them and have you start thinking about what kind of contribution we might see. So I'm going to start. People mentioned nuclear, and so I'd like you to think about nuclear. And one note, I think I can pull up, I happen to have some of these other slides for nuclear, and really want to just make sure that we can, I think we do have just some more grounding in what would be going on with nuclear. Yeah, so, and this is a little bit about how we do this, that here is our nuclear baseline. You can imagine we have to be very careful that when we test something like this, we're consistent with how others think about it. So here is, see that blue line is En-ROADS baseline for what would happen in the future with nuclear under the baseline, with no changes. And you see this IAEA low. This is a number in 2060. That is their number for what the International Atomic Energy Agency thinks is possible. And see this IAEA high, see that green square? There's the high number and there's the low number. So we're very careful to say, what does the International Atomic Energy Agency think is going to happen? We also compare it against those other integrated assessment models. So you can see for 2050, we're kind of in the middle of everybody else. By 2100, some of the other models think that it would be higher. We happen to be higher on wind and solar. So we compare against them. That's where we start. So I'm going to go back here and show you what we have for nuclear. And here is the scenario for nuclear. See that blue, that light green area. I'll pull it up. What you just saw, final energy consumption types, nuclear. I'll actually do it as primary. under nuclear. So there's the future that we start with as a baseline. I want you to think, what if we subsidized it extensively so it grew a lot more? That is much more like above what the IAEA thinks is their maximum, the high scenario. So we're going to go above the high scenario. What do you think this temperature of 3.6 degrees is going to do? How much is it going to go down? So we're going to go to a new poll. What do you think the 2100 temperature would be? Simulated in your head. Everybody, all decisions are made with models. You're going to make it with your mental model, the one between your ears. So 22% think under 2 degrees. Maybe this is a silver bullet. Some people think 3.4 to 3.6, 3 to 3.3. What do you think it will be under this scenario? And really think about what you understand of the whole climate system. Boy, people are really, 58% of you think it's 3.4 to 3.6, 21, 3 to 3.3. But some people do think perhaps it is a silver bullet all the way to under 2 degrees, 2 to 2.4. 54% of you think it's here at 3.4 to 3.6. Okay, this is exactly what we need. You're doing so well with these polls. Love it. Fantastic. Okay. Half of you think the 3.4 to 3.6, a quarter think it could get all the way down to 3 to 3.3. Okay, you ready? First, I'm going to just subsidize it here. And so here we go. Boom. Oh my gosh, I had forgotten what instead of, this is now way above what? Double, triple, 4 times as much. So way above what those other simulators, we can look and see what 60 exajoules by 2050. We ought to compare. It's really good to see where we are. So 60, we're way up here, the same as this high. See this black dot at 60? And then by 2100, pardon me geeking out, but I really like looking at specifics, 120 by 2100. So we would be way up here. So a lot more. Now let's try it using this replay last function. See, I'm going to hit here, replay last change, and we'll watch again. Now, mind you, on the top left, the y-axis is changing. That's why that line's going down. But you see the reduction in pollution. How much less pollution do we get? Greenhouse gas net emissions go down, but not that much, and the result is 3.5. So most of you were right, only a modest change. Now, mind you, this is helpful. We need a reduction of 3.6 to 3.5, very important, but it's not a silver bullet. And I see a lot of messaging people up. If we only allowed more nuclear, we could solve this problem. However, you need to think about what it's doing. Why would it help? And mind you, we get a similar result even if we get a lot more. I'm gonna imagine not going to 120, but we're gonna have a breakthrough in R&D cost reduction. What if it went up to 200? Then you get to 3.5, or even more, 3.4. Most of the simulations show a relatively modest effect. Why is it helping? Well, it's displacing some coal, which is very helpful. That has some beautiful other impacts as well. When we think of multi-solving, we think of actions that have multiple co-benefits. Invented here at Climate Interactive by Dr. Beth Solomon, the idea that we should look and capture co-benefits such as air pollution, less coal, PM 2.5 emissions. These are the particles that cause so many deaths from heart disease and lung disease. Less air pollution. This is fantastic because it's keeping coal safely in the ground. What about other things like natural gas? It is cutting natural gas. But what else is it cutting? It's also eating into that future that we imagined for wind and solar. It is competing with wind and solar, another zero carbon energy source. Of course, it's not going to pick its competition and only take out coal and gas. and it's relatively modest, and it also takes a long time to kick in. The existing energy infrastructure lasts about 30, 35 years. So it's going to take a long time for the coal and gas to leave and the new nuclear to come in. We need cuts not in the 2040s to coal and gas. We need them in the 2020s. So because it's delayed, it's having less of an impact. So it's no silver bullet. It could possibly help, but it is no silver bullet. So there's our first test, the modest impact of nuclear. All right, so let's try another one. You mentioned so many good ones. Trillion trees, so much interest in the trillion trees, and focus on that. So I'm gonna ask you the same question. Let's actually go back and do it. I'm going to clear responses and try again. If we had a trillion trees, people around the world, now mind you, to do this, we would have to plant trees in lots of new areas. There would be challenges to the people who live on the land right now. And mind you, this is not urban trees. This is plantations, mostly. To get to the scale of a trillion trees, this will be kind of growing trees more like crops than intact forest ecosystems. However, let's test it. What do you think the impact would be with a trillion trees if we had that impact around the world? Now, mind you, what are we doing? We're planting trees. We're finding spots around the world. We're planting those trees. They're growing, and steadily photosynthesis pulls carbon out of the atmosphere into the trees, fix it in the soil. 51%, 3.4 to 3.6. And again, about a quarter. This is very similar to the last one, but some people think it's 4% and you think it's a silver bullet. It'll do it all. All right, let's go try it. Trillion trees. And here we're not going to look at energy. Let's go look at removals. And over on the top right, I'm going to show you another graph which shows you the sources of all the pollution. This is that same graph of showing you greenhouse gas net emissions, but it shows you where is it coming from. Land use CO2. This is from chopping down forests and mostly for agricultural land in Brazil and Indonesia. Here, energy CO2. See this big dark area, burning coal, oil, and gas, F gases, methane, nitrous oxide. Okay, those are all the sources. If anything happened of removals, that would happen below the zero line here. Those removals are going to be added up over on the top left. Okay, so you made your guess, trillion trees. To get a trillion trees, we need to go above our maximum just a little bit. This is one of those areas where we let you dream big. Why not? As a what if test, what if this maximum land, I think this is more like 840. We took some numbers here of like what's possible, 840 million hectares as the max available land. Of course, many of the sources are here in these, in the little, you hit the triangle, you get to see the sources. What if we had 840 million hectares? And we knew if we were to plant trees on 840 million hectares, now mind you, this area is the total area of China and the United States spread around the world. This is a lot of trees, okay? This is a lot of land. I'm gonna crank it up and ready, here we go. There it is. I'm gonna run it again. You see that big growth up to, what does that get up to? About 7.8 gigatons a year being pulled out of the atmosphere, and the result, a modest, again, in this case, 3.5 degrees. Now, mind you, it's the same result, but modeled totally differently than the nuclear, but happens to get us the same result. You can see what it's doing. It's taking the land use CO2, which is emissions. Here you see how it's positive, and now it's negative. It's going to below zero. So you can see the result there below zero, pulling carbon out of the atmosphere. But you wonder, why is it not that much? You can see, because at the same time that we were planting trees, we were emitting all of that carbon dioxide from burning coal, oil, and gas. So a really modest impact relative to what's getting put into the atmosphere. So one is just the scale. The other is the timing. It takes time to find the land, plant the trees, but mostly for these trees to grow and slowly, slowly pull carbon out of the atmosphere such that it reached this peak out here, 2060s, 2070s. As you know, if you've learned about climate science, we need to be reducing emissions really over this next 10, 15 years, not waiting 30, 40 years. Now, some of the assumptions here, we can say, well, we've assumed that it's going to take 10 years to find the land. Well, we could say, no, it's only going to take 3 years. And that makes it a little sooner. And over 30 years, we plant the trees. No, we could do it over 12 years. And that makes it a little sooner. And then you get 0.2 degrees, still a relatively modest impact, not a silver bullet. But we're going to watch later, this could be part of other actions that really help. Now, I mentioned before multi-solving. Multi-solving asks us to try to solve multiple challenges together and at the least address equity. And with addressing equity, we need to make sure that the implementation of climate solutions doesn't create new problems. And one big area to look at here will be how much land are we talking about for removals? In this case, to plant 1 trillion trees, we would need, what did I say, 840 million hectares. That is over 2 times the area of India. Much land. And you have to ask, who is living on that land now? What is being grown on that land now? Possibly in agriculture. What are the effects on food markets? Important equity questions as we think about climate solutions. Okay, so far we've looked at 2 challenges. I've asked you about some of the things that may have less of an impact. We're just looking at 2, as people mentioned, carbon capture and storage as some of the others that perhaps we could look at. I'm going to go back here, and actually we've talked about this effect on removals from afforestation. I'm going to go back to it, this 1 trillion trees here. But there are many others that are being considered. Bioenergy carbon capture and storage under this area where we could imagine more. It's similar. Another, say, 0.1 degree would be bioenergy with carbon capture and storage. And of course, runs into similar problems with land for growing. That's even more land than that would be used for growing trees for removals. When, as we see with this stacked graph, here we would get more in the negative areas. You see that? See that gray area? We're now pulling some out, but it doesn't address the big challenge of burning coal, oil, and gas and what it's doing to blanket the earth, increase temperatures. So let's go to another question. I know there were more that you suggested, but I want to start shifting to some of the better news here. Let's get some better news. And some of the better news is, so what should we be doing? What do you think are the most high leverage actions that are out there? So I'm going to ask you to choose up to 3 policies, and we're going to try some other policies and see if we can get all the way down to well below 2 degrees, possibly 1.5. And hopefully this is now launched. We haven't shown responses yet. I did this one where you can't see all the bar charts changing. I really want to not have you influence each other as much. So we'll see what we've got. I've activated it. Oh, heck, I'm too curious to see what you're coming up with. Okay, here it comes. Let's see. What are you choosing? Encourage renewables, discourage coal, set a carbon price, reduce methane and other gases, energy efficiency in buildings and industry, a clean electricity standard. All of these wonderful ideas. We're giving you 3 votes. You're getting to see now the results of all the different policies you'd like to try. Set a carbon price, discourage coal, reduce methane and others. Right now, people are voting most for a carbon price. Fantastic. Great to see. All right, Caroline, helping me to remember, let me see. Would you vote for it? It was a carbon price was number 1. Number 2 is go after coal directly. methane and other gases, and energy efficiency. Okay. Thank you. So let's see, how do some of these do? So I'm going to redo this. And actually, maybe this is a good time, Clara and Caroline, send the simulator again. If you'd like to multitask and watch this and try something else, try some of these yourself in the simulator. We're going to send it to you. And also, if the hook is in your cheek, maybe folks send the link to the training site. You can learn what's underneath the hood here in the model and learn how to engage others. You know, I'm going to go with coal first. And a lot of people, when they see this future for the brown area of coal, they think that's not going to happen. And so I'm going to go right under here to a somewhat buried policy. I want to make sure we get to it. What if we just stopped building new coal infrastructure? And actually, let's try it here. See, we're going to go back with this one and previous. I'm going to try the next, and I'm going to clear responses. What if we were able to ban the building of new infrastructure, coal infrastructure all around the world? You're starting, what do you think? No new coal infrastructure. No new coal infrastructure. And the coal infrastructure, we don't just stop it entirely, but it slowly retires away. The average lifetime is about 30 years. So we're going to have it slowly fade away. Most of you think 3 to 3.3. I know I'm doing this really quickly. I just want to get a quick, most of you think 3 to 3.3. I'll bet your mental models are getting better and better. So here we are. Stop building new coal infrastructure. Are you ready? Yes, you are right. It makes a huge difference if we could get coal to do what? If we got coal to go slowly all the way to zero. There it is. Slowly fading away, all coal. Now, mind you, one challenge. Look at the graph here. As we do it, what do you see happening to the width of the height of the blue area of natural gas? There's a little bit of the squeeze the balloon. You ban it, and it's like when you squeeze a kind of squishy balloon, squeeze it here, and it pops up somewhere else. We're seeing some more growth in natural gas. So there's some shifting there that doesn't help us quite as much. However, what a huge impact. And of course, if we got even more where we could cut it even more, watch in the brown area, if we just cut utilization even more, 3.2 degrees. One big reason why, what year does this policy keep coal in the ground? Here in the 2020s, did you see those other policies that were so delayed? Growing trees, or the overall policy of an alternative like nuclear energy competing with coal. This policy, keeping coal on the ground now, cuts emissions here in the 2020s. That is what we need in order to get those emissions down and get the temperature down significantly, 3.2 degrees. All right, I'm going to undo this one and try another one, which was setting a carbon price. There are many proposals around the world. There are 52 subnational groups and nations that have a carbon price, many cities and regions in China, regions here in the United States. What if we had a carbon price? And I'm going to crank it up to $100 a ton. Citizen Climate Lobby here in the United States is proposing one here. A carbon fee and dividend, give the money back to the public. How much do you think it's going to help? What do you think? $100 a ton around the world. Is it a silver bullet? And why? So try it. 3 to 3.3, 2.5 to 2.9. This is what you seem to think. All right, keep voting. This is great. All right, 2.5 to 2.9 is where most votes are. I'm going to move on because I just want to keep us moving along. All right, so here we go. We're going to carbon price. Don't just think what the estimate is. What is it going to do? Why is it going to help that much? Here comes 100. Are you ready? Hold your hats. 5, 4, 3, 2, 1. All right, 2.9, a huge contribution with $100 a ton. Now, mind you, after $100 a ton, it could rise up even more. And you can imagine, and here in the model, you could say after 10 years of cranking it up, it could go up over 50 years to a much higher level. And there, suggestions of going, super high, and then you get all the way to say 2.5. It's not a silver bullet. It is not a silver bullet. Now, mind you, this carbon price is affecting the energy system. You'll see what else is needed to address climate change. It's not addressing emissions from deforestation, methane, nitrous oxide, F gases. Those would be a methane price or an F gas price or a nitrous oxide price. So this is an energy CO2 price. There we are at 2.5. I'm going to actually undo that. We're just going to look again at $100 a ton. Why does it help so much? $100, here it is. What is it doing? See the green area, more wind and solar. Look at coal, oil, and gas. All of them shrunk. Less coal, less oil, less gas. And the when is important here in the 2020s. It keeps greenhouse gases out of the atmosphere very soon and immediately. It has another interesting impact. What does it do to energy demand? Prices are higher. There is an incentive for energy efficiency and conservation. This is driving energy final consumption to grow more slowly. So energy demand is depressed a bit. Now, when we think of equity, there are challenges and also good news along the way. Let's think about the challenges. One challenge: how do we handle the fact that energy gets more expensive because it's taxed? There is the cost of energy goes up a good bit. We need to be careful what happens to marginalized communities that pay a disproportionate amount of their household income on energy, putting gas in the tank to drive around, to pay for electricity, to pay for heat. Well, some of the proposals would be to use the revenue, and there is significant revenue, in this case, $3.2 trillion a year, $3.2 trillion a year in revenue from this carbon price. Perhaps give it back to citizens, give it back to people who are affected by this policy. That's the downside on equity. The upside, I showed you before about air quality. This is going to really change the coal consumption, coal burning. Therefore, air pollution gets so much better immediately. Look at PM 2.5 emissions implicated in so many deaths around the world. Gets better. Think of healthcare costs, comorbidities to COVID-19 with respiratory problems. See that drop of emissions. Current scenario, the blue line going down. So this is an incredibly powerful policy, and it's not a silver bullet. What else do we need? What else do we need? And so I'm going to let you click the dots this time. What are the other things that I should click here in the model? So I'm going to open up. So you've seen the simulator. Click the dot about which other ones. I've already clicked the carbon price. We're going to add on top of the carbon price, methane and other, deforestation, more renewables, economic growth, energy efficiency. Oh, you guys are doing this. Caroline and Claire, this is great. We haven't tested this one as much. They're doing it so well. Electrification, energy efficiency. Wonderful. Less coal, methane, renewables, energy efficiency. Fantastic. Okay, so many votes and so many things. Electrification and yeah, these are great. Okay, I'm going to try some more now. Great to see your votes. So many on energy efficiency. So let's try that. What is needed to get us well below 2 degrees? What is needed? We have a carbon price. Now, people who voted for coal, we have already done a lot to bring coal demand down with that last policy. However, why not bring it down more? In this case, I'm going to have with energy efficiency. Watch what happens in the long term, if we add on top of this carbon price more on energy efficiency, this is an economy that gets more and more efficient with its energy use. This is an economy now where energy demand is just about flattened. Energy efficiency in transport as well. What if the way we get around energy systems, buses, cars, trucks, even more efficient, energy demand coming down? Now we're at 2.6 degrees. People wrote about electrification. That could help a little bit more, particularly if you decarbonize the grid. This is a grid that has been decarbonized. More gets shifted over. Did you see that last move? And I want to show, let's go back to energy demand. And I'm going to hit this back button. Watch, if you hit the back button, then it goes two less. It's not a silver bullet, but combined with policies that decarbonize the grid, electrify everything, as supported by many of the climate thinkers these days and energy thinkers, is another contributor to well below 2 degrees. Here we are, 2.4. What else did you click? People know deforestation, because look here. Now we can see in this graph, what are the sources of greenhouse gas emissions? Do you remember where we were before with that dark area growing and growing? Now it's thinning and thinning, but there are other sources. The green area of land use CO2, absolutely. So watch, if we cut deforestation emissions, watch the green area at the top right, less, down to 0, that's another 0.1 degree. Okay, even growing some more trees could help a little bit more. 0.2, methane and other that you suggested. That, in this scenario, methane is the biggest source of greenhouse gas emissions. So in agriculture, landfills, wastewater. Now a question, what is happening to methane already? What is, run your mental model. Be a systems thinker. What is happening to it already? Go and look, what's happening to methane? We're already reducing methane a lot. Wait, we haven't touched agriculture. What's going on? One of the hugest sources of methane is leakage from the oil and gas industry, particularly the gas industry. Natural gas is mostly methane. So when you have less natural gas, you have less leakage in the system and less off-gassing. Therefore, methane emissions go down already. What if they went down even more? This one surprised me when our modelers came through with this one. Watch the 2.2, a full 0.3 degrees all the way to 1.9, well below 2 degrees. What if we get down to the maximum of what some of the modelers think is possible? Then we're down here. Fantastic. Encouraging renewables. Now, people say more renewables. We already are encouraging them indirectly in this scenario. So what is happening with renewables? They're going up. And why are they falling? Energy demand, because of so much that we're doing with energy demand, we don't need as many renewables under this scenario in the long term, which is really good news. Now we could have them grow even more, and that gets us to 1.8. So we're so close to 1.5. We know we want to get all the way to 1.5. What else could we consider? Well, this is a time when we might consider some of the technological carbon removal, which most modelers agree is necessary to get us down to 1.5 degrees. If we did that, it requires a good bit of carbon removal. There is a scenario fairly consistent. I'll say, well, we'll see. Is it consistent with some of what was published in the recent AR6 report? Yeah, their report, the one that the IPCC shared, had net CO2 emissions in 2053. This is a little bit later, net zero in 2053. Here with greenhouse gases, net zero in the second half of the century, 1.5. This has been so intense, and I've been kind of hollering at you. But I hope you can see there's no silver bullet. No one thing did it. There's no silver bullet. I heard Bill McKibben say that first. He said it to the world. There's no silver bullet. There is what he called silver buckshot. I like to say it as that there's no one, it takes more than one seed to plant a garden. It takes more than one seed to plant a garden. We've planted many seeds. it's still possible. It is still possible to make a scenario such as this happen. It is necessary to keep coal, oil, and gas in the ground, not burned in the next decade or so, not just in the longer term. With that being said, I'd like to just slow down for a second. I've been hollering at you so intensely about this. And I'd just like to slow down and just think for a second. Look at what is happening in this world. We're investing in new technologies such as electrification. We're figuring out how to have collective action around the world, people pulling together to set legislation such as a carbon price, such as policies that encourage renewables, that decrease deforestation, that plant trees around the world, that reform how we do agriculture, that figure out ways in new industries such as agricultural soil carbon, that implement energy efficiency in our personal lives, but also as communities and society. What would you love about being part of a world on track to making this happen? You personally, what would you love, love, love about being part of a team, a business, a civil society group, a faith organization, a state, a province, a country, a business, a world? What would you love about being part of this? Not what would you do, what would you love? I'm going to be silent for 60 seconds. I'm going to set my timer here so it happens. And here comes the timer. Let me see, stopwatch. 60 seconds. I'm going to be silent. Let's just be silent together. What would you love about being part of this, a world like this? Here we go, 60 seconds. That was a minute. Okay. Please write into poll. What would you love? What would you love about being part of a world on track to making a scenario like that happen? Cleaner nature that we get to live. Wonderful. Less fear, healthier environment. It would provide meaning, a better hope for our children, a world free of self-inflicted suffering, better future for the next generations, relief, can look my children, grandchildren in the eye, not facing guilt over our trajectory. Caroline, can you unmute and read some of these?
Yeah,
please?
and I'll grab some out of the comments too.
Yeah.
Commitment and understanding the necessary action to grow a future in a healthy world. Peace of knowing humanity will survive in harmony with our planet. Biodiversity fully promoted. Social and environmental justice. Climate justice. A world free of self-inflicted suffering. Hope
So
for our
wonderful.
children's futures. Avoiding extinctions.
Oh, rethink to have a child. Oh, wonderful. Love to see people actually accept the idea of changing their practices, teach their children, be a model for neighbors, survival, security, be part of the solution, introduce En-ROADS to others. Wonderful. Thank you. We would love to be part of that world as well. I want to shift us back here. Along the way, many people have asked about the new report that came out last week. This big report came out from the countries around the world signing off on the scientists sharing their papers, 4,000 papers about where we're headed. And notice this scenario, and I want to just connect the dots between this and some of the headlines that you certainly have seen. And in particular, this one it's important. I think it's important. Like this headline the New York Times wrote, "A hotter future is certain, but how hot is up to us." I think this is an important framing that we could adopt and you might consider. They said a hotter future is certain, but how hot is up to us. A hotter future is certain, but how hot? And we dug into this. Where did they come up with that? Why did the media write that? Well, in the summary for policymakers. Claire or Caroline, can you send a link to it? If there's something to read from this report, read the summary for policymakers. B1 says global surface temperatures will continue to increase until at least the mid-century under all scenarios considered. That sentence is very important. And I want to show you where you can recreate it in En-ROADS and see it. How did they come up with it? Well, they pulled from those models I talked about before, the integrated assessment models. And their results are here. In particular, see this SSP1? It is one of the scenarios, 1.9. Go watch the training on confidence building. I'll show you how we calibrate to their model. So we've recreated it, and it's not unlike the model, the scenario that you just looked at. This is from the report. If you dig into the training, you can see this is the SSPs. There are 5 of them. I showed you that was SSP1. It's called sustainability. You can learn more about them. I already showed you some about how we calibrate to them and the different baselines. But there's a framing which we've often said is this: we're going to need to manage the unavoidable. Temperature is going to go up till mid-century, and avoid the unmanageable. How does this show up? And that is avoid those scenarios where the temperature goes up to really high levels post mid-century. That's what we can really change. Here's what it looks like in En-ROADS. So see the scenario that we just created? Let's look at a different variable, temperature. Temperature. Okay, this is our 1.5 scenario we just created, pretty similar to the one they looked at. Here we are in 2021. You see that? Here we are, about 1.2, 1.29. Some of the data that you'll see from the recent report uses data going back to 2019, 2018, but here we are, temperature going up, up, up. See it rising until departing from the baseline, but still going up until the 2040s, 2050s. The bad news, folks, and I'm not gonna lie to you, temperature is going to increase until mid-century. Those scientists just reconfirmed it. So one big challenge for us is to manage the unavoidable. We need to be ready to handle what's coming. Now, one note on our simulator, we're going to show you some of what we're adding. This is not online right now, but we think it's particularly important over the coming years and months to add some of these results, such as decrease in crop yield. It's hard for me to even just, deaths from extreme heat. I don't want to be glib about how serious this is to imagine that in Southeast Asia, there would be 9.3 additional deaths. These are real people. And we need to imagine how we could avoid the unmanageable. The actions that we take, as you just saw, with actions will help us with scenarios that get well below 2 degrees. I'm making one here, make these lines much lower. We can get well below 2 degrees. You see those policies to avoid this. And also people talked about sea level rise. We're going to be adding, and this is a sneak peek, this has not been released yet. We have these brilliant partners at Climate Central who have partnered with us to include some of their sea level rise maps in different years. This will be coming later in En-ROADS. Manage the unavoidable. See their temperature rising. So when you engage other people with this tool, help them get serious about caring for people who need to be cared for as we think about the world heading through 2050. But after it, we look at the difference. Actually, even in 2050, look at where we would be at 1.6. Under the base case, all the way up here above 2 already. So when that headline said, you saw the headline from the New York Times, it said, and it's true, a hotter future is certain. How hot is up to us? What we invite you to do is to take this tool and help people figure out what it would take to get on track to shape how hot it actually gets, to make this blue line happen and not the black line, because this is unmanageable. We need to avoid that unmanageable future. All right, it has now been 1 hour. So what I want to do is to close out with a little bit, if I can buy 5 minutes from you and just tell you about some of these possibilities for moving forward, but also invite you, if you like, to stick around. We're going to stay on the line and answer more of your questions. So some of the possibilities, again, could you send the links, Caroline and Clara? If you want to learn how to engage other people in your own language, in your own setting, whether it's business or your students or your community group or government, come take the course. It's online and free. Become what we call a climate ambassador. The final thought, though, to leave with what we hope would be interesting to see. We'd like to see, what are you going to do about this? Here we are. Perhaps there's a question in your mind. Perhaps there's a challenge that you'd like to give yourself. What does this lead you to want to do? Let's close out by saying, what does this inspire in you and the people that we've pulled together from around the world? What does this inspire in you? So please write into, what are you going to do next? Share this idea. Wonderful. Run 1,000 workshops. Run them and register them on our website. Become a climate ambassador and push for change. Buy local, no packaged food, repair versus buy new. Develop new informative tools. Use it in your classes, wonderful. Consider more sustainable building products and systems. Finish the course and use it like you've recommended. Okay, fantastic. Run a workshop with your government team. Increase awareness. Caroline, can you read some?
Yeah, I also see one in the comments, which is contact Congress and urge carbon pricing, increase awareness, discuss with Minister and President of the Imperial University in Japan, sharing, run more workshops, teach other people why we need to act, engage in brave climate conversations, taking the training to innovate a curriculum at the Slovak University, it's excellent. High school teacher gearing up to use En-ROADS for professional development for our faculty to expand use with students, create awareness, have my students learn how to use the simulation to develop a strategic
Wonderful.
plan. And to all those who are already using En-ROADS or planning, please reach out to us and share. These programs and ideas sound fantastic, and I'll drop the support page. We just want to hear about what you're doing.
Fantastic. This is wonderful to see. This is wonderful to see. And so I know you've stuck around for a few extra minutes here. We appreciate your patience. All right. So we've taken quite a journey together. You laid out what are the things that you're concerned about. We looked at a bunch of lower leverage challenge solutions. We've identified things that perhaps we need to do. We need to plant trees. Other solutions that may be lower leverage may be part of putting together many actions that together will get us all the way there. But there's no silver bullet. Instead, it's more like silver buckshot. It's still possible. All these scenarios keep coal, oil, and gas in the ground in the next 10, 20 years. There's so much that you would love about being part of the world on track to making this happen. And we have bought a certain amount of warming. We are going to need to prepare our communities for warming that is coming already. And there's so much that you can do. Overall, my friends, it's not going to be easy. It's going to be worth it. Go get them, everybody.